model name Sunglow VMII 5000 48 volts operating system. All the inverter is make on some topologies, not search for specific model. You need to have knowledge about topologies and some continuity and some voltages. Not search, man. Not search the specific modeling. Not search to watch the specific model video. I am also explaining this thing. I am also explaining this thing. Do not search for specific model. Like this is the brand. Cut this brand. I'm giving you an example. Let's little wait for viewers. Minimum one person required to watch until I am waiting. Hey YouTube AI system, I know about. First you need to read the screen and audio system, but after my live stream, the people are not watching the live stream, and I am also working in live stream. Okay, one person I found. Cut this brand name. Okay, this technology is shipping the products without this brand name. You need to search for this model name like this. Zoom. Model name Sunglow VMII 5000. You need to search for this model number, not for this brand. Like I have a max power. Okay, cut this brand name. You need to search for model name Sunglow VMII 5000. Sign up. It's okay. Let's get repair because I am already very angry. I am very sad to receive this control drive card, and this is the expensive. Here we can purchase an 89 USD and other expensive components we have, and we need to repair the PCB, main PCB. So the repairing cost is very high, and finally the customer said, I cannot afford the repairing cost. Just close again. I give an example of APC, American UPS manufacturer. I'm very sad the world is going fall down again, not rising in technology. They are falling down again in dark. And our people, they keep our people in dark. Just take how much devices I have in my workshop, and I am just a single person in my city to repair. How much inverters I can repair in one day, and 8 to 10 hours. I'm not responsible to repair 10 and 12 inverters in one day. How I can? Just check, they are just selling the products. After that, they are not responsible to provide you a microcontroller to just replace this microcontroller, not complete control drive card to purchase an 89 USD. And this people is responsible to provide you just microcontroller, remove and push to install the microcontroller. But where is the immunity? Where is? I not found immunity. I'm just removing the top core first to repair this inverter. And if I found a damaged control drive card, I think the same result. I cannot afford just close again to keep on the side in house. How much USD they spend on this device? Man, thinking about just on money. I comment somewhere with an angry mood on grow art. I don't care about my top pen badge. Remove my top pen badge. I don't need to have your top pen badge. I have my own personality. And the people are know me from 2004, 2004, from 2004 or 2004. They make change the world with this cheapest technologies. I can repair. It's not the thing I have not the knowledge. I have the full knowledge to repair this inverter. I also repairs in live streams. Make 11 hours and 7 and 8 hours continuously to repair this cheapest thing again with low cost. But when I receive a damaged control drive card, and this time I am very angry from this technologist, why they design to just replace the whole control drive card. Why? Little I need to remove this APC 5000 PCB from here. Show you. I attached this PCB on in my workshop. I'm loving this engineers who think about the humanity. Show me where they glue. No any glue. They are just design a PCB with techniques. You can repair very easily. No any component we have on this bottom side. And this is the control drive card of this inverter. Just check the engineering. They are not thinking about money. This is the 2005 model. Just check. APC. The people are not know about now. Who are the APC? APC also think about the humanity to provide light in dark. And now some people are rising with money concept. Just check. This is the control drive card. Okay? To repair, not through and scrap. And I purchased this beautiful circuit in scrap. I have a call. Hello? जी आका तस तो मुस्तान सर राबिता हो कहीं डबल कपड़ा ही डबल लेकर इसमें لازم هذا مرمتنا ده ما تشكر ها okay, let's remove the top core first. Just think about, they cannot install on this bottom side SMD components in 2005. This is the real engineers. Huh. Just check the high frequency transformers. Man, I said in this days. I need to remove now. Chiefest BMS is in the world, keeping in dark. Also. First, provide per little time a light with solar energy. You need to use the solar energy. Why you are not installing the good UPS of APC company? And you need to install a MPPT charge controller to charge your batteries with high current. Well, we have issue in our country, electricity. Then why my audience also from US and UK and Germany, and why the people are watching my live streams in US, UK, Germany? Yeah, because the people are facing difficulties with these machines. This is the second one, and I am also providing a message on platforms, and I am investing more money to promote my video, to provide the message more people to please. Raining, the weather is rain. Not strong English, but I can explain. I am also providing message in bad weather. Please turn up your PV switches and your utility input breaker. In this case, 3 to 4 days ago, I provide a message on social media and I promote the video. Please keep your devices safe. And after this, I received 2 inverters in this condition. The first one is Grow Art, and the second, this is Max Power. I think I have the same issue. Control drive card is mentioned, I think, but let's deassemble to check. Why I am angry when very upset in these days. Because I am thinking about other side. We have more thieves to give you bad notes in currency. Just check. Approximately 1 USD yesterday. I get this notes in the middle of other notes. This is not able to purchase something, and this is the wash note. So now the people mind. I'm very sad that this zip tie and do not through first, because you need to install again, like a reminder. A grid electricity now cut. Okay. And for 1 hour, the people in the dark, because the time is now. What the time here? Gloves cannot feel. It's okay. I don't care for viewers to use the lamp. Leave. To do just my work. People who are interested to learn, watch. Who are not interested, leave. I am not care. Also, I need to explain everything. One hook is here, hidden hook. Install air ventilation. Go. It's okay. Now just sit on your position. C2 at gaming. Hi, how are you, man? In these days, I am very sad to know about these people. So I'm very upset. Yeah, first, we need to remove this connector with ports because we have not any hook to push and easy remove. Need to apply ports. The side here we have glue, but not found in this. Okay, what about here? We have one more strip glue. Have or not? No, no any glue. It's okay. One more strip required to remove. Okay, this is. Just check the hard wire to install with control drive card. Cannot provide like this soft material silicone difference. Yeah, PV negative and PV positive. I am celebrating the exhibitions to meet new bodies to sell. This device is more to keep the people in the dark. Have childs, females, we have some weak elders. They need to have again emergency lights. Some people who found the way to provide a power unbreakable, untriptable, UPS, untriptable power supply. And some people who found just a way to earn money. Cheapest humans. They are just providing a 1 year and 2 year warranty, and after that they are not responsible to provide you microcontroller and spare parts. Huh. I contact so many time with Growart, but they are not giving me a response. And finally I comment in very angry mood, but I not use bad words. I just comment true comment. And sometime later I will share you they need to remove the top pen badge from my timeline, from my Facebook timeline, but I am not caring about to remove the top pen badge. I am not accepting this type of people who have not a human mind. And some Chinese people stay here in Pakistan, living in Pakistan, to create the business more, to provide this type of technology, to connect the grid neutral or the grid line with the PV voltages. Why? I'm talking about this sharing technology, high voltages supported inverter, 450 volt PV supported system. I'm talking about this. Man. They are saying that Pakistani is our iron brothers. We are not your brothers. If our country people are supporting you, but I am not accepting you, Mr. Chinese. You are unresponsible people. Unresponsible peoples. I remember about Honda, who sent the generator part from Japan to Pakistan in 2000. From Japan to Pakistan, single part of fuel generator, electricity generator. They are not responsible. I have conversation of one grow-out seller. I ask about I need to have a grow-out SPF 3000 TL control drive card, and they said, where you purchase the control drive card. This is not your company. You are selling the products with grow-out brand, and you cannot provide a control drive card here. Why you are selling the products in our country if you cannot provide a spare parts and control drive card and microcontrollers? First I need to clean. Here we have some carbon, and how we can check the control drive card. But first we need to remove the short DC to DC boost section MOSFETs, and how we can remove and how we can power the short MOSFETs in this parallel MOSFETs. We have 16 MOSFETs in this inverter, and how we can pound or find, I can find. On the side we have broken English, but one day I will learn. Man. We provide a UPS to people in 2006, and now they are using 19 years. After 19 years, our UPS is able to provide electricity in dark. Some people are using now our UPSs and just uninterruptible power supply to charge the battery from utility and to provide the electricity from battery. And these people jump in market to create here a solar charging system, and they control all the market all over the world. And now this is the result. Just test. People just test now. And now I know about, they again come and low frequency transformer with high resistance. I have some proof. Now they are making again. So the vision is now they have to sell again the low frequency devices. Then why you invent or design the high frequency? Other side you are again advertise the low frequency transformer with iron cores to have some resistance, because the next plan is that to again sell the low frequency transformer devices like 50 hertz, operating on 50 hertz. And here we have 35 to 36 kilohertz frequency and 9 transformer. First we need to operate the 9 transformers, and after that we can get the output voltages in the dark, in the night. Now they are selling again the low frequency devices, advertising about the screws. think the thermopad. First I need to little move. The board is moving. It means no any screw we have on this because the board is moving. So we need to little force apply here, and we need to little wait for this to remove the thermopad. Okay. Okay. I was talking about this thermopad. Okay. Remove this little body beauty. Angry man. Okay. Remove this with force. No any option we have. Okay, now how we can pound the short MOSFETs in this parallel MOSFETs. Just learn the method to remove from this beauty machines. Okay. Now keeping this Luke guy to tell about this cheapest engineers. Okay, MOSFETs, 4 MOSFETs we have in parallel. I need to little zoom out first to cover the area. It's okay. Focus on this. Pin 1 gate, pin 2 drain, pin 3 source. Already we have in parallel drain and source. Just check. Short. Okay. Now keep the positive. First you need to keep the negative on pin 2 drain and positive on pin 3 source. Short circuit. Okay. Now positive on pin 3 source, negative on pin 1 gate. We have 47 ohm resistance. And what about the gate drive resistor? 47 ohm. That's okay. I hope and I think and I'm saying that we have one MOSFET or 2 MOSFET in this 4. Okay, now check again. Positive on pin 3 source, negative on pin 1. To know about, okay, 47 ohms. Again, okay, we have 0 ohm resistance. I am explaining with schematics. Okay, how? Just check. Another side we need to design this thing to balance the lithium batteries of these people. Now how we can found? I need to draw here. Little, does not matter. To repair. Let's suppose here we have MOSFETs, 4 MOSFETs. Okay, 4 MOSFETs. Pin 1, 2, 3. First I need to write here. Pin 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Pin 1 gate, 2 drain, 3 source, gate, drain, source. Okay, make pins first. Okay, we have 47 ohm resistor here. Just check. Okay, again for this we have same resistor. For this same resistor. For this same resistor. What? 47 ohms. Okay, 47 ohm, same value. 47 ohm, same. 47 ohm, same. 47 ohm. Now This is connected in parallel. Okay, and this source is connected already. Connect this source. Already we have a connection like this, 100%. Okay, the drain is connected with drain. To do little with red marker to guide you. Okay, jumper. Okay, again jumper. Okay, again jumper. Okay, drain, drain, drain. Focus. Okay, now the resistance from where coming, 47 ohms. Just check. When I keep the positive on pin 3 source, and here I keep, and we have 47 ohms. This 47 ohm resistance, 47 ohm coming from this. Okay, and why we have not more than resistance? Because we have one short MOSFET, so 47 ohm. Okay, and short with one MOSFET. Now I need to remove and show you. Let's check more how we can remove specific shorts MOSFETs. Okay, forget 47. Okay, it's continuity mode. Okay, number 3 we need to mark here on this 3. Marker is not working. Big marker little. This. It's okay. I marked number 3. And what about another same process? This is the push-pull topology at full bridge. Full bridge. Okay, short circuit. Okay, what about more? 31. Low resistance. 2. Okay. 3. This poor MOSFET I need to remove. That's okay. What about more? Already short. Okay, we have not short MOSFET in this 4 parallel because we have a true continuity of integrated circuits. Okay, this continuity is coming. It's okay. Now what about this number 4 MOSFETs? Okay, short circuit. Check gates. Why? This is connected with this another, so the gate continuity is true. First we need to remove 1 from here and 4 from here. 1 from here and 4 from here. I have called from home. Hello? How, Marja? Huh? Ha, Papu Churgude? Ha. Okay, sorry for that. Let's remove this first and this 4. Okay, the 47 ohm is required to have for gate. Okay, quick remove MOSFET number 3 from this side. That's okay. MOSFET number 3 from this side. Okay, and this 4. I need to check an open circuit. Okay, and I'm checking. Don't worry about. First we need to provide here a hot air to remove the MOSFETs without damaging the thermopad. So you need to provide here 300 degrees centigrade hot air to remove this MOSFET without damaging the thermopad. Other MOSFETs is already connected with heatsink. Okay, now little force apply. Check. Just quick. Little force apply from here. Okay. Remove. Now I need to separate this from heatsink first. And searching for best tweezer and make specially for this situation. Just check. Check the thermopad condition when I remove the MOSFET first, and how you can remove MOSFETs easily in this set. Okay, first I need to set here. Okay, MOSFET number 3. The good tip is for this, you need to have the K tip. This is the C tip, C shape, and I need to install the K tip. I'm installing the K tip. Okay, and set temperature on 480 because the high temperature is here required. First pre-solder all the fins, okay, to make a good heat contact. And here solder. It's okay. And now hold the MOSFET in tweezer, but do not apply the force. Little force required. It's okay. And now melt first all the solder. And this full bridge topology MOSFET removing is very difficult because there we have a lot of copper metal. First we need to provide heat for some time. Okay, I need to boost again my soldering station and keep always on 480 to remove this MOSFET without damaging the MOSFET pads. First I need to apply here for source and drain because this is the big soldering. More time required to melt the solders like water. After that you can remove the MOSFET without damaging the PCB. Or it required, wow. Little more required to remove without force. Little force like 50 to 80 grams. Okay. I remove, and if you have doubts, no any print come with pins. Okay. Oh, why not check this first? Okay. Drain, source. Okay, wait for it. Short circuit remove from this pole. So okay, now remove all this four, but first we need to separate from heatsink and just check the thermopad status. I remove with technique, not with force. Okay, you can check the thermopad status, and here we have not the thermopad, so I need to separate first with this tweezer. I am removing with this tweezer to separate first from heatsink. It's okay. More to remove easily. It's okay. And first of all, we need to provide here hot air to heat this copper material. We have a lot of copper. Set this four MOSFETs here. Provide here hot air. Remove the nozzle and provide here 400 degrees centigrade to heat first this. Otherwise you cannot remove the MOSFET. You need to have 180 watts soldering station. Then you can remove the MOSFETs from this full bridge topology. You can remove without hot air and push-pull topology, but you cannot remove from H-bridge topology or full bridge topology. So I am providing here a hot air because this copper conductor is connected here with this source, and after this here connected with this transformer windings. So you need to heat the transformer pins to remove easily the MOSFETs. And just check, I am for a little more time providing hot air, and after that I need to remove the MOSFETs. Okay, now I need to try quickly 480 degrees centigrades in K-tip. But yeah, I need to set this. I think I provide to another MOSFETs. I need to provide here. But I not waste the hot air or electricity. Already connected with this source. But little more heat. That's okay. Now check MOSFET 1. Okay, make a good heat contact first. So okay, now hold in tweezer. Provide heat. More time required later. Easy from first, but not enough now. I need to provide little more heat. Okay, remove. Okay, no any friend come with pins, and I need to show you the pads, but first I need to remove all the MOSFETs. Okay. The drain pin and source pin, and you need to touch the tip with source and drain, and need to touch the soldering iron tip with source and drain pin. Hold in user and easy remove. Okay, or next. Now need to make heat contact or get pin with solder and touch the soldering iron tip with source and drain. And little time required to melt the solder properly. It's okay. Removed easily. Another right here solder with 480 degrees centigrades. Okay, hold in user. Okay, as you removed. Now first check the continuity. Okay. Pin 2 negative, pin 3 positive. It's okay. This 4 in parallel. Now what about this? Another. I remove all 4, so how we can check? It's okay. Now check this third. Okay, true continuity. What about gate? True continuity about gate. Okay, this last. Okay, I remove the short circuits, MOSFETs, and now I need to check the control drive card. And now we can check because I remove all the short circuit from here. And now first check the control drive card, but here we have carbon. I need to clean this first with liquid. Oh, liquid, man. Can I not purchase today? And the market is nearly closing and I need to purchase on the time now. Oh man, I am coming back in just 5 minutes, and here I need to write because the new person are joining the live stream, and this is not the good thing to wait. Unknown wait 5 minutes wait. Okay, I'm coming approximately in 5 minutes. I'm just searching about my door keys to lock my workshop. I am coming back. Yes, the people can read. back. I come and I purchase the liquid. Okay, first I need to wear my gloves. Remove this tag now. Okay. First I need to remove this to get little in this bottle. And after this, I'm filling this bottle for using little. First I need to cut the seal here. Okay, and one thing more, cut like this to get the liquid and the air are sucking with this hole. Okay, this is another tip for you. Get some little more. I need to keep safely. Okay, I had little. Okay, now I need to fill this bottle. To use easy. That's enough for this suppression. That's okay. Just attach the nozzle and little clean. Now you can use easily like this and clean. And you can wash and you can clean. It's okay. Inside. I think the wash is good for this. Why not wash? I need to wash. I'm washing this here, not on my bench. Okay, for that. I washed the board clean. Now I need to dry. Dry. Okay. I think the card is okay, but I need to check, and I need to check this MOSFET later. I need to just check the control drive card. And yesterday I used a lot of time, and after spending the time, customer cannot afford. And this is the reason to be upset. It's okay. I'm just providing voltages to hear the beep sound. Positive. Decrease the power to not generate spark. And connector. Because here we have a big capacitors. Now increase smoothly. No any short circuit we have, that's okay. Provide true voltages first. Operating voltages, that's okay. Now provide here switch. Where are you? Okay, this is the switch to first off. And first we need to listen or hear the beep sound. Turn on. Yes, okay. Good news. The control drive card is okay. Now I need to work in man PC. Congratulations, man. Congratulations. Okay, now what about the PCB? This is the PCB condition. I am also objecting. Do not install here the variester. They don't know about the electricity. They can know about just the electronics to make a pulses with microcontroller and make some high frequency and feedback system. Otherwise they have not the knowledge about electricity. It's okay. From where start? From here we need to start the operation for this. But first know about the DC to AC converting section area to tell the repairing cost first. So man, okay, how we can check? It's okay. IGBTs, pin 1 gate, 2 collector, 3 emitter, okay, negative on 2 collector, positive on 3 emitter, that's okay. True continuity. Oh, okay, short, this 2 is short, that's okay. What about the middle IGBT? Short, it's okay. And what about this? It's okay. It's okay. It's okay. It's okay. To remove these 3 IGBTs. But before this, what about the bus of start system? And what about the wake up system? This is the wake up system. This small PCB are waking your device without battery. Okay, if you are not connecting the battery and you provide the electricity, this circuit is responsible to wake up your system. Okay, in there we have also a fuse and anti-C, and here we have 1000 volts MOSFET. So I need to check this to tell the true cost of repairing. So little knowledge discuss about this high voltages solar charge controller. They are not charging your battery directly, they are just increase the PV voltages or decrease from 450 to 380 for backup mode, and for charging mode I need to make a 450 volts on bus voltages. Okay, let's just check first from electricity utility backup system. Here we have one fuse. Okay, we have continuity and 1000 volts MOSFET. Here we have, let's check this. But we have fuse. If I have a short MOSFET, not expensive, I can install from my side. Okay. What about this IGBTs to install for boost and buck converter, like, okay, this diode is okay, and this IGBT is okay. Two IGBTs in parallel. Okay, now I need to first inform the user about the repairing cost, not be later said. Okay, but the contact number person give me and not give me a contact number of this user. I not received this. I am also receiving the contact number, but here I have my brother and they are not thinking about the contact number. But let's repair, man. The people are believing on me because I am not a thief. I'm a true person. It's okay, remove this variator. Start from this to repair this inverter in this live stream on first try. First try me, turn on and get output voltages on first try. That's okay. Variators here, it's okay. Two variators. We have a tool for this. Need to keep here. Variator pins. Okay, here install two variator. This is the fence. It's okay. And here we have tools to remove easily the components like this. This one is very good. Focus, man, focus. It's okay. C-type. Okay, first I need to try C-type, K-type, K-shape, but the C-shape is good for this operation. If I not done, I need to replace the tip. It's okay, connect here. Okay, now provide heat from center and hold the component. It is not enough now. I think this tip is not good for this operation. Little I am trying more. Okay, remove. But this tip is not good. I need to replace the tip to install a C-type in 180 watts. Let's get started, man. Wow, rapid action. Okay. create heat contact. Little wet. It's okay. Now, here. For this. Remove the extra solder first. Soft nozzle. Shield rod. Desoldering wick. Desoldering wick. C-type. So, to use desoldering pump, little more. Boost now. Boost till near. It's okay. But I am not installing there again the explosive devices, surge protection devices. This is not the surge protection devices. To install here. It's okay. Later we need to clean, okay, all the holes. But I'm not installing, but I need to clean for another person. If another person interested to install the variator here, I am responsible to clean this. First we need to know about the PCB tracks. In this operation, you need to remove again the relays like yesterday and clean all this. Okay. So we have one chance to start to remove the relays and capacitors, all the components. It's okay, man. Set on the chair properly and get one component. Box for components. Okay, get box. And for relays, also we have a good tool. I keep it here at so far. Why not upgrade this? This is not upgraded, and I need to upgrade this tool now to remove the relays easily. Little time required to upgrade this. And how? Just check coil pins. It's okay. If we upgrade, we cannot use here. I think I make this with this vision. Okay. First create here contact to hold for you conductor. Okay, now here make contact You need to use solder a lot if you are thinking about the PCB. Okay, connect one contact here with this pin and one here with this pin. Okay, the contact are created, and now just melt all the solders at a time. Provide here heat. Okay, here first, because this is the big soldering. And a little force need to apply, but not now. First you need to know about all the solder is melted. The coil pin is easily removing, but the common and normally open pin is little stuck. Wait for this. Okay. For this. For this. Okay, and as you remove the relay, and I need to show you the PCB. Don't worry about the friends. Okay. No, another relay. So first we need to know about the pins. This is the coil and common and normally open pins. Okay. This is not my first time. Oh man. Set the conductor first. That's okay. Heat contact. It's okay. And another, but not no, not no. It's okay. Why not try, man, to improve our work? But this is little lengthy, and I need to cut here another conductor to make easy our work. What about? Yes, I think this thing is good. Why not try? To keep on this center. I think we need to make perfect tool for this. I have one more piece. Why not check? To remove more easily. Okay. Now just set the conductor. It's okay. What about the relay pins? Not removing now? No, they want force. We need to little wet to melt better. Little force required, but I am not applying. I'm just with no. Like contact, man. here you need to keep. Wow, fall down, relay fall down. Okay, now remove this conductor with care. Okay, take care about the components. The third relay is where okay, here. So later I need to set here coil and common, normally closed, normally open. What about wow. Oh man, you cannot use this for this, but you can use, you have a little pieces of copper. Ah man, I like Goldsmith. Okay, just start the operation. It's okay. Solder this here. Set the position. Connect with coil pins. It's okay. Yeah. Make heat contact. In this case, we need to check the relays. Okay. Oh, again, I have call from home. Hello. Marjan. Sishe. हाँ Sishe Amur da mobile di warka Mor di mobile warka ها توس واحد موبایل ورکې زما سره به خبرې وکړي زه به ته په دې نه پیسې باندې ولېږم ته لاړه شه وې سواله ته واحد د ځای نه ما ته ټلیفون وکړه ورشه اوکې سوري فور ویټ the chairs you need to little guide with little high volume if they are not understanding so you need to apply high volume to understand it's okay what about I have two soldering station. Why not make like this? Fall down automatically like previous. I think I need to apply little force for this. because all the fin is melted. Okay, little force I think required. Smoothly removed. Come on, do not fall down. It's okay. It's okay. I remove all the relays. Now let's clean with C-type. Oh no, sorry, K-type. C-type. I'm trying with C-type to remove the extra solder first with this soft nozzle. Okay, more with desoldering wick, and one or two shots with desoldering pump. Oh. Okay, one relay, coil pins with desoldering wick because this pins is thin. Why not make first completely? Okay. It's okay. Stop. Okay. It's okay. And just check the prints. Okay, I cannot install relay. Okay, what about more pins? It's okay. This. Okay, I Imtiaz Muhammad 911 star. So Why? What is this, man? I cannot understand, Imtiaz Muhammad, your comment. You're talking like in Pashto and English mix. We will. I'm speaking Pashto in my daily life. Sorry, I touched the smartboard with my head. What this bad? Boost again for more 30 seconds. That's okay. More. Okay. More with desoldering wick. Okay. Again boost. Desoldering wick is shrinked. I already told about shrink. Temperature. Why? That I need to use here. Liquid, not power. Let's cut this shrink area. I need to activate my soldering tip. Let's check. Boost. Oh, it's shrinking. What about the temperature of this soldering tip? At 350. Boost and little. I need to create again the heat contact. Required little solder to make again. Yes. No. It's okay. It's okay. It's clean. for this. Okay, coil pins. Coil pins. One coil pin is here. Screen. The one is here. One relay. This pin. This pad. One. Another relay is here. Clean the pad. Little more. One, two, three. It's okay. Solder particle. Oh, okay. Oh, very small. I need to like move from here to here, and finally I get. liquid. Set the bench. Oh man. Required to remove. 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 Wow. Start from this inductor. Enjoyable. This capacitors, sorry, resistors to like sap from just solder connection contact. Put it here. Two. Two. Is this? No, this is not the good brand. Yeah, I need to have little bit. No, cannot use this. This is for another component. Quick. Mac. This. Little more. Done. It's okay. Little more bend. Check. for next time. 9 AWG conductor. Little I need to set. It's okay, it's done. I'll just put solder and get ready for this. And hot air. To help with soldering station. What about apply here little force? I think what is this? No. Okay, go. Little more heat required. Why not check with another soldering station to help with this? Wow, fall down finally. Okay, remove this thing on the time. And fall down. This is the techniques. And you need to keep this for next time to not make. It's okay. I remove this size of inductor with this technique. Okay. It's just about. I remove this. Just check. Okay. You can remove this with this method. What about more component history? This is the solders. And this capacitor I need to remove. One capacitor, two, three, five, five capacitors I need to remove, and this too. I need to remove this too. Okay. Start from here. So this is the thing to keep. We need to have lot of 9 or 8 AWG wire to use everywhere, easily desoldering the 2 pins components. Like you have long length. I have already the tape, but I'm sharing you. I'm sharing my knowledge with you also. I have already a tip to just melt at a time and remove. But I am providing a data for you. Okay. Just here little. Okay. And here. Connect. And easy. Remove. Isn't it remove? Give me this thing on the side. What about this? 1, 2, 3, 4. That's okay. This 4 components. This is 1, 2, 3, 4. It's okay. I found. Here is the tool. this. What the component? First I need to know about little bit to. It's okay. No about. Oh, this capacitor. Okay. Just hold and fuse. Right here. Easily. One is here. The component. First. Bended pins, but removed successfully. Okay, one more here. Cleaning, okay? Don't worry about this. Let it. It's okay. One pin is spalted. What about the second pin? Here we have remove. Spalted. Keep the components here. What about the top side of this board? Okay, now we can clean perfectly, but this is required to remove our best duty. Again, call from what the man? Hello? وعليكم السلام خير आगे के लग गया है मुझे मैं आगे पाइप किलो वाट याद होगा ना आगे किधर लग गया है हाँ लग गया है हम पके हाँ कार पके कोमा सबा बटिक की गई इंशाल्लाह Yeah, I receive call for this inverter. Unknown person, but I receive call. The person give number. And finally, I receive a call for this, and I told him, I am working, and you are inverter. Don't worry. When I clear, I need to call. just receive your inverter. Okay. Hold and top fuser. Wow, like wheelchair. Easily. Don't think about assembly components. Focus. गम है मेरा गम कितना कम है दुनिया में कितना गम है मेरा गम कितना कम है. Remove all the components and now we can clean with a very easy method. Finally. That's okay, man. Let's just enjoy the unique live streams. You cannot pop live streams like this without me. Okay. Start the operation, man. Little time required to get my tablets. Oh man, I'm starting. Okay, I'm starting. It's okay. Step by step, we need to work. Why not wash? Just wash easily. First, the extra carbon. I'm planning to wash. First, I need to keep this thing. Brush. And liquid. Retarder liquid. Okay. What about flow? Not need to hold. Just right here. Little flow. Direction. That's okay. And set this. Okay. Now you can wash easily without holding the board. That's Okay, done. There we have transformers, and we need to remove this transformer to clean the carbon, because here are generating high frequency or IGBTs, 37.5 kilohertz frequency. Here are generating. Just check the condition of board. More we can clean with cotton swabs. More with cotton swabs. What about my bench? Oh God. Dust. We can clean with cotton swabs easily. Right, hot air. Zoom out, man. Okay, later. Wow. Cloth. Clean my bench. Components. Later wash. And check the capacitance. Okay, dears. I need to go in washroom. So little bit, just for 5 minutes. I'm coming back. Okay. Imra! Imra! Sabar, Zaida. Yeah, I'm coming back on the way. Sorry for that. I'm just wearing my gloves first. Sorry if I come late more than for 5 minutes, but I come. It's okay. Let's little sit and sit on the chair first. Now, clean this. Why not? This board is little length I have, so why not keep this on the edge to provide facilities for me? Oh, it's okay. Easy to work. First of all, I need to clean this carbon from here. I need to zoom this area specific. Just check the condition of PCB. Not damaged like previous PCBs. I cut this complete area and I provide a new empty PCB and I install a copper tracks. And finally, I repair the inverter. I run a load over 1800 watts in live stream. The video title is Anverex 5.2. You can watch. Approximately 10 days ago, 10 to 12 days. Receive some cotton swab. You cannot clean this 100% with brush. You need to work like sweeper. You need to provide force and receive the carbon from PCB. And if you are feeling this sound, this is the good sound to clean. And you can know from this sound. Receive a lot of carbon. Okay, more cotton swabs, more cleaning. The burn fiber I receive 1 fibers. More. More. This area is important. More cleaning, we can more clean require to remove this solder, the small mountains first, like mountains. Stop, man, stop. Stop, man. Oh, alarm at 30 p.m. here. Okay, clean. And extra we need to cut. Spalted copper. A beautiful degree, not cut 100%. Cut here. What about this? Here we have a little more spotted track. Cut. This is not business, it's just duty from creator, universe creator. I want to leave this field, but first I need to set here a person to do my duty like me. And after that I need to join another field because I not on. Because if you are working like this, you cannot on. But legal way, you need to earn with legal way, not like these people are just earning, not thinking about after the selling. Okay. And now just thinking about the next plan. What about this transformer? Okay. To remove to confirm this, but later, not now. Now remove the IGBTs in. We need to replace all the components at a time and turn on first try and get output voltages on first try. If here we have a broken or D value or burn gate drive resistors, so we need to focus on or think about the control drive. And if we not receive a broken or D value or burn gate drive resistor, so don't worry about more. And here I have a knowledge to share with you. Let's suppose here we have a 4 IGBTs, okay, in backup mode, they are working. To make the AC voltages from DC voltages with pulse wide modulations, okay, and here if you receive a burn, broken or D value drive resistor, you need to work here, and I discussed already so many times in my previous live stream. I received so many broken, burn and D value resistors, and now I am checking, okay, 28, 48, okay, the value is here 47 ohms. You can check this with ohms or with continuity, both, okay, 8 ohms, but you can receive here a beep sound. It's okay. This is the third gate drive resistor. It's okay. And this is the 4. It's okay. And in the middle, IGBT, same value. It's okay. Now let's little talk about this side. If here we receive a broken, burn, or D value resistor, so we need to work on control drive. But first you need to check, here we have our gate drive 22 ohm, okay, so first check this, that's okay, 22, for next second, it's okay, for third, it's okay, for 4, it's okay, but not one thing. If you receive inverter and someone work and just replace the resistor, so you need to work on control drive and you need to check. And I already told about this drive and how to check with oscilloscope. You cannot check this drive with multimeter DC voltages. You need to check with oscilloscope. The required frequency is 37.5 kilohertz in 33 point some percent duty cycles. Already I discussed this a lot of times. It's okay. So in this case, we have not the burn, broken or devalue gate drive resistor, and little more data I need to share with you. Here are installed the 18 volts zener diodes. We need to check this diodes, zener diodes. Okay, true value, true value. Here we have 8 zener diodes. Okay, true value, true value. Why? Okay, first we need to remove the IGBT, and after that we can check this. Why? Check this. No man, zener diodes is shorted. This zener diode is, yeah, 80 ohm, 80 watt. But we need to remove the short IGBTs, because here the gate is connected with source just with some turns. I'm talking about this high frequency transformer. The source is connected with transformer windings and gate two connected. So first we need to remove the short IGBTs, and after that we need to check again this zener diodes. So why not remove the short IGBTs now? Okay, let's check and mark. This is true continuity, true continuity, true continuity. Oh, we have true continuity. Okay, what about the gate? So the true continuity, 22 ohm connected, true continuity, true continuity. Okay, then why there we have a short zener? Okay, let's remove the zener diode and check the board value. Okay, I'm removing this zener diodes first. If I am removing with hot air, I'm not liking this. So I need to remove this with soldering iron. Little this I need to provide here heat at a time and make a contact just with solders. Okay, where is my user? Here, it's okay. This zener diode. Now I need to create again the contact. Okay. Easily. Little force required. Here we have a glue. I want to remove this zener diode with true body, not broken. A little force here apply. Here we have glue. Okay, I broke the glue or broken the glue. No any print damage. The zener diode I removed successfully. And if you are checking the component, just solder the one pin here to not disappear in reading time. And now you can check and open circuit. Okay. Wow. Zener diode is short. Okay, remove this. The value is 18 volts and the marking code is here J3. Okay, jumper J. jumper J, and digit 3. 1, 2, 3. Okay, J3. Okay, what about the next diode first? Why not check this? Okay, the true value. Now check the board value. It's okay, it's connected with this. So I need to install here one single zener diode. Okay, what about this? True value. True value, okay. Just one zener diode was short, and I remove. Okay, where is the J3? J3 man, just call me. I am here. J3. Okay, I found. J3 voltage is 1 at 18. 1 required here. Now keep more on the time. First clean this. Okay. Clean. Okay. Add little salt first. Here. Here. Hold inducer. Think about the polarity. Okay. I set R in true polarity. Just providing now hot air. This is the reason of hot air. Or this. Not this up here. It's okay. Perfect. Okay. Now remove the short IGBTs, and first I need to decide I am able to repair in this one single live stream. I think the 9 p.m. and I can stay here 11 p.m. Now the time is 9 p.m. And no any copper tracks we need to make, so I can repair this. So I am deciding this. I need to repair in this single live stream. So let's quickly remove the IGBTs and clean the pads and everything, and check the relays or install new relays. But first we need to check, and the diode pull relay we need to replace. Okay. But first I need to remove the short IGBTs. I am little sitting myself for this operation. let's get started. First, know about the short IGBTs to mark. It's okay. It's okay. This 3, number 3, number 4, and number 5 from this side. Okay. 3, 4, 5. If you are confusing, just mark on this solder, not on PCB, okay? Because you are already removing the solder. So let's try how you can remove easily the IGBTs without damaging the thermo pad. So first of all, I need to cut this, or we can cut the PCB tracks. I am also against with these people. Why? Because they are providing everywhere the glue. They cannot install the heavy components with knowledge and technique. What about if I cut here? But here we have a thick copper line, so little I need to cut, and 1 mm I need to keep here because I don't want to scratch the PCB or cut the green solder mask. So I'm cutting here little because you cannot remove this without cutting. Okay, I keep some. Okay, and now how we can remove this. First of all, you need to set your soldering station for 150 and provide here to this single side first, and we can use our technique, but you can use it two methods. Use our self technique to make here another type of conductor. Why my soldering station is not boost? Okay, now boost from 350 to 450. Melt this solder, okay, but the requirement is that first you need to know about all the solder is perfectly melted, and apply force for this side, because first you need to know about the solder is melted, and you need to break the glue. Wow, man, what your suggestion for this situation? We need to more cut. Just check everywhere they are providing the glue, making difficulties in repairing. So I need to little more cut. Here we have not the thin copper line, but we have track. Just cut like people are cutting the bananas, okay, like this direction, not to this. Okay, now try again. Set your soldering station. Melt this solder first and make sure solder is melted for both sides, and it's okay. Remove. I broke the glue, and now for this side melt first and apply force, because we have no more options to break this glue. I not cut this with nib. Just check focus, man. Focus. Why not you are focusing? Okay, so you need to pull up to break this glue. It's okay, it's done. And the cleaning operation is later, but check no any print come out. Okay, this is just the solder, and we can clean this. And here I think we have little solder. The time I need to remove this, because later we can forget and this thing is can damage our inverter again. We have no more chance to remove this capacitor, and now we can remove the IGBTs. Okay, so here apply 400 degrees centigrade hot air, and you remove your hot air gun nozzle. And first, oh man, I forget one thing. First, little loose or rotate this anti-clockwise. Okay, this IGBT is mentioned, but we cannot remove this with here with the straight screwdriver. So for this case, you need to have 6 mm nut driver and just try. Yes, and you can remove this with 6 mm nut driver. Up here you have this type of screws. Okay, now provide here hot air to remove the IGBTs without damaging the thermo pad or isolation pad. Some people are called isolation pad and some people are called thermo pad. I am calling thermo pad. Okay, first here provide hot air to heat the IGBTs and thermo pad and heat sink. After that you can remove the IGBT without damaging the thermo pad. Otherwise you cannot remove. And if you have another smart technique, so you need to share with me. I have just this technique to remove flat driver is required, flat screwdriver is required, and not near me. And I am applying hot air and searching the flat screwdriver, but we have time. First I need to hit this IGBTs, and I do mistake. What type? From this side 3 to 4. It's okay. So again 1, again tight, apply required post. No man, but you need to here install a same IGBTs. Okay, again remove. One thing is another you need to know about. Okay, I am talking you little time later because I heat up and heat sink are cooling again. Why I am removing? This is the supernatural help to lose all the screws. With mistakenly, but this was the help from nature. It's okay, here is the flat screwdriver now. Oh, bench is not clean. Also keep clean your bench. And why I not clean? Because I am very upset in this days. Okay, I lost the connection, so in this time I provide more hot air. I lost the connection, so in this time I provide more hot air. Just attach to this IGBT with this another. Okay, I broke the bond, and for this just it's okay, and for this it's okay, and for this I think this the angle is not good, so I need to set this on this direction, and for this you need to attach here. It's okay, and for this okay. Now remove the screw completely. First I need to little better view for you, not upside down. That's okay. To remove the screws and check the method. Is this method successfully or not? If I damage the thermopad, this method is not successful. And if I not damage, so we can call this method is good. That's okay. Screw there. I magnetized yesterday my screwdriver and now I cannot keep in box without touching other hand or other thing. Okay, now we cannot use this screwdriver here. We can use this here, but this variator is disturbing me. Oh man, later. Why I am not using the 6 mm nut driver with degree. This is the engineering of misters. And now I am trying with this screwdriver to remove this IGBT. Yes, and we can remove this easily with this type of screwdriver. Keep this in the box. That's okay. Now let's check the method. Now separate completely from heatsink and from thermopad to remove from PCB. Okay. This thing is not good. In the middle IGBT. Do not touch the thermopad. Okay. It's okay. I separate this from heatsink. And I hope I not damage the thermopad, but we can know about. First we need to remove all the IGBTs. And our old technique. Okay. Right here. Solvers first. 480 degrees centigrade is required for this TO 247 packages. Holding fuser. And easy remove without damaging any pad. Again for this, here little solder, here and here. Okay. Now hold in fuser, melt at a time, and easy remove the IGBTs are TO247 packages components. Hold in fuser first, ride heat, and easy remove for next. Okay. Some people are using desoldering wick, a lot of desoldering wick, but I cannot remove successfully because this is the one method to remove without damaging. Hold in diffuser, melt, and easy remove. It's okay. Just check IGBT spin. No any print come out from PCB. Okay. If I found this. Okay, keep this IGBTs here. And how you can check properly the IGBT with the multimeter. This is the another knowledge I need to share with you. How we can check the IGBT properly. Okay. Set your multimeter, continuity mode, and note one thing. You can check the IGBT or MOSFET. You need to have inside battery 9 volts NIDA. Okay, 9 volts NIDA battery. If you have in your multimeter, you can check the IGBT. Pin 1 gate, pin 2 collector, pin 3 emitter. First keep the negative on pin 2 collector. Now we cannot call this IGBT as okay. Why? First you need to reverse the polarity. Positive on pin 2 collector and negative on pin 3 emitter. And now here apply the gate voltages to gate pin. The voltage is coming 7.5 voltages, negative here, positive here. First check, okay, no any continuity we have. And when I apply here a gate voltages to active, I apply. Now we need to have the continuity. And we have this IGBT is okay. People are checking and solder the bulbs, and some people checking with some methods. This is already short, so keep here short. Okay, now to check this another short. Okay, keep this here, check this. Okay, keep this here, last one. Okay, we have internal resistance, but we cannot confirm, we cannot call this IGBT is okay. Reverse the polarity, provide gate voltages and check. Now we can call this IGBT as okay. It's done. And I need to cut the fins first because I am using pull-out IGBTs. I also share the data with you. I'm welding the fins to pull out IGBTs because I cannot found in our country original IGBTs. So many times I purchase, but I just get a scam. So now I am using this fins. It's okay. Through and scrap now. Okay. This is lateral. And what about to follow the full basics? The full basics of this, how much drives we need to have in backup mode. I'm just counting. If I cannot, I need to come live again tomorrow, but we need to follow the full basics because this is the dangerous thing for repair master who are repairing for herself or for pupils. So we need to follow the full basics. And how we can follow? We cannot provide here a voltages. If we have here, I remove the gloves, sorry for this thing. If we are providing here a voltages without this IGBTs, we can damage this bridge. Okay, we can damage this bridge, and for 100% confidence, we need to check all the drives. How many drives we need to check? 9 drives. For this section, I removed IGBTs. I'm talking about this section. 9 pulse wide modulations to check properly for this section, and pour another pulse wide modulation to check for DC to DC boost section. But for DC to DC boost section, we can measure the true continuity with multimeter. Okay, and another side, we have much more power supplies in this type of solar inverters, but the important is this 9 pulse wide modulation. First we need to check this modulation, and after that we can install with 100% confidence. Yes, our pulse wide modulation is perfect to operate this IGBTs. Okay, and we can check this section with multimeter. Okay, we can check this. Don't need to remove this all MOSFETs. Okay, and what about the MOSFET number? Oh, okay, 100E08 and 1. Oh man, I cannot find this original in our country. I have 100% proof. I have, but not original. So here I need to install the same voltages, same amperes, and same brand MOSFETs. After that, I can believe on my repairing. Okay, otherwise, if here I install for another one brand, and here install another brand, and here install another brand or another manufacturer, I cannot run my this device properly because I need to run the 4800 watts load on this device. I need to remove this all MOSFETs and install here same brand, same serial number, same manufacturer. Okay, so the time is not enough to core this all operation in this live stream. Okay, and check the thermopad status. No any pad damage. Here we have little solder particle here. Okay, and I remove this. Okay, I need to clean this. So other requirement is that you need to remove this transformers and clean this area because this is the high frequency. I'm talking about this transformer, high frequency, and you can watch tomorrow. Okay, and I need to give a same title like how to repair a Sunglow VMII 5000. I need to give a same title. In the middle, I am not coming live with another device. This is my rules. First, clear this device in live stream, and after that I need to discuss more devices. So the time is here late and I cannot complete this operation, and I need to start this operation from here tomorrow if God will. Okay, and this time I need to weld just this pins, but in live streams you are boring also, so I need to tomorrow first weld this pin because I have a short length pins IGBTs 100 amps and 650 volts. I purchased pull up and I need to weld this pin first just without live stream. I need to do just this thing. Okay, and take care. I remove the gloves, and tomorrow if God will, we need to work more and check all the pulse wide modulations and of same brands, but I need to check the voltages first. This is the 80 volts and 140 amps MOSFET, and tomorrow we need how to check the MOSFET voltages. Okay, little one brother comment, IVR Lobo Sores Saludos des Bolivia. I need to translate, but I cannot hear. I cannot copy from here. So please, if you have in this live stream, just translate your message to English. Okay, how we can check the voltages to confirm this? How we can check the MOSFET voltages? I have little doubts. Maybe in these days my knowledge was not enough, and I repair and I receive some complaints with this MOSFETs, and I get this again. This 5 pieces. I check the NF like this. I am sure this is original. I remove from board. I found one piece with true resistance. The number is K100E08N1, and here we have the same number. Okay, K100E08N1. Little number scratch, but number we have same. And how we can check the voltages? This is the 80 volts MOSFET. I am trying to share this knowledge with you, and I need to end the live stream. Okay, first of all, you need to install here a gate to source discharge resistor. You can install here 10K, or you can install here 49.5K. This is the famous resistors. Here I am installing 10K with ohm law. I can install here. I am just checking this MOSFET's voltages. That's why I have doubts on this. I need to check is this the 80 volts or not. So I am soldering here to later cut. No need for cleaning. Here with source and gate, you need to connect the 10 kilo ohm resistor for 80 volts MOSFET. If you are checking the 80 volts, you need to know about the voltages of MOSFET in the real time. You need to connect the 10 kilo ohm source with the gate pin 1 with pin 3. Okay, and other side you need to solder here a little wires. To attach with crocodile clamps power supply. On the side we have analog multimeter, milliamps multimeter. I'm soldering here one wire and another. I am guiding you, don't worry. Not yet. Connect with drain and source. Okay. We are not using the gate. We need to know about the MOSFET voltages. It's okay. Here with source pin 3. Okay. And now here we have an analog multimeter to use here. A milliamps. Here we have 100 milliamps. Okay, first of all you need to check your analog meter to provide here little voltages with this 1.5 volts battery and some resistor. I install here 50 ohm. Okay, my multimeter is working well. Okay, this is the amps. Wow, working with amps. Now what about more knowledge, more data? So I need to literally keep on side. Okay, and now I'm showing you everything. Don't worry about this. First I need to install the crocodile clamps to my Fluke 179. To show you the voltages here. Crocodile clamps and okay, first attaching here probes and set on DC voltages. Okay, and now here I need to apply the negative. I am not using this multimeter for daily routine, so the probes is damaged and I keep. Okay, now this is our output voltages. Okay, so the pin number 2 is drain. If you are passing the positive voltages, you need to connect with drain, and if you are passing the negative, you need to connect with source. So here I am passing negative. Okay, so I need to connect this with negative. I am soldering, okay, because no more crocodile clamps to attach. Here is already the cheapest wire. I am attaching here to check the MOSFET voltages. Is the number is back or not? Okay, solder. Here I provide negative, so I receive in red wire negative. Okay, here I am applying. First I need to attach the multimeter with power supply. I connect this negative with power supply negative, and I can receive 105 voltages from my power supply. Okay, here I connect the negative and put voltages. and here I connect with pin number 3 negative, because here I apply. Now I need to connect this voltages to first show you the input voltages. Now I have 50.7 some voltages, okay, and little give me a time. Okay, I am attaching this drain. Source I connect with negative, and drain I am connecting with the positive, and just look there. Okay, I attach, but little microcoil clamp is damaged, so I need to little if I attach this here, and I can attach this little wire. Oh man, first attach this and this, okay, and now attach here. Okay, now in this time no any consumption we have, okay, because I apply 50 volts. Now I'm increasing the voltages to know about and how much voltages the multimeter amps is showing you. Okay, 53, 54, okay, 60, 61, 3, okay, 66, so okay. Now any amps throwing, it's okay, 72, 73, 74, 75, 76, 77, 80, I'm checking, 86, 91, 95. Okay, let's check now. This MOSFET is not 80 volts because they are limited. This is the 100 volts MOSFETs, because 99 voltages, and when I am increasing from 99, so there we have consumption. Just check now, they are closing the circuit because the MOSFET voltages is nearly 100 volts. This is not the 80 volts. Okay, let's suppose decrease the voltages, and I remove this MOSFET, and I remember this is the original. Okay, now let's check. I'm just connecting this resistor and this wires with this MOSFET to check the method is true or not. We receive a consumption on 100 volts, and what about this? This is original. Okay, so I need to first remove the gate to source discharge resistor and these two wires. Okay, the negative I already attach power source first. Now here I am attaching the gate to source discharge resistor to not damage the MOSFET, to keep gate off. It's okay. And here now I need to just connect with this source. It's already the same conductor, same continuity. I am attaching here for easy soldering. Okay, and the drain I need to remove from this MOSFET, and I need to install here to this MOSFET drain. Let's just know about on how much voltages. Okay, I am increasing the voltages now to know about. Okay, 12, increase. Okay, no any consumption we have there in my amp meter. Okay, 61.7. Okay. If we found on 80 volts, 76, it's a little increase, 80, wow, 90, same result, 97.6, 99. Wow, we have same result for 100 volts. Okay, now what? Why I call this? This is the 80 volts. Am I wrong? I need to check the data sheet of this MOSFET. But we have same result on 100 volts. It's the 100 volts MOSFET or the 80 volts. If we have the 80 volts, then why they are switching on 100 volts? Okay, the MOSFET number is K100. This is the good MOSFET, but if you have original K100, what about the number K100E, capital E, 08, capital N, and 1. Check the data sheet with me. Okay, go to check data sheet on datasheet.com also. Okay, K100 ISC. I need to check the data sheet. What about the voltages? Why the 80 volts in my mind? Okay, where is the voltages? Drain to source voltages 80 volts. Drain source voltages 80 volts. Then why they are shunting on 100 volts? Yeah, right here. Need to know. Think about other side. We have CSD 19505 KCS. Why not check? This is the 80 volts. Little solder. Check the data of this MOSFET. Why? We have the 80 volts MOSFET and can observe the 100 volts. Let us know about drain. Source and get. This is the TI component, Texas Instruments. Little difficulties. Okay, all thing is okay now. Just increase the voltages to know about this MOSFET. All thing is same. 50. Okay. 74, 76, 78, 80. Wow. And 85. This is the true data. On 85 volts, we have switching. This is the drain to source voltages. 85 volts, and the MOSFET is already same. We need to know just about it. But they said this is the 80 volts, and they are limiting on 100 volts. And this is another side, we have a TI instruments, TI. Okay, first I need to little wear this gloves to keep here this MOSFET. This is the TI component, Texas Instruments. As you can see the Texas logo. I am also using this, but now I have not this. CSD 19505KCS, the world best MOSFET per 5 kilowatt. But remember one thing, if you have a full bridge topology, okay, or DC to DC boost section, if you have a full bridge topology, you can use this MOSFET. This is the world best MOSFET, CSD 19505KCS, Texas TI. Okay, they are limiting on 85 volts, and other side we have on 100 volts. And we can use this MOSFETs because we receive a same data. The MOSFET is original, but I think I was wrong. This is the 2.5 years ago situation. I decide this MOSFET is not original, but maybe my knowledge was not enough 2.5 years ago, and now I have knowledge to check the MOSFETs voltages. Okay, dear friends and brothers, take care. And tomorrow first we need to install this 5 MOSFETs easily, and we need to remove the IGBTs to follow the full basics and repair with full basics, if God will. See you tomorrow. Take care. Best of luck.